Hello everyone, all my dear students. In our last video lecture, we had seen the modulation index and the percentage of modulation. We also seen what happens if the modulation index having the under modulation or the over modulation, or we can say what happens when the modulation index is very high and the modulation index is very low. Now we have to see the sideband and the sideband frequencies. If you will understand the video lecture, then hit the like button, subscribe the channel and share the video with your friends. Let's go on the screen and see how the sidebands are generated and what are the sidebands. So the sidebands are we also called as the side frequencies. The sidebands are we also called as the side frequencies. But the question comes again, what is the sideband or what is the side frequency? As the amplitude modulation is done as a part of the process, here the different frequencies are generated. These different frequencies are we called as the side frequencies or the sideband. As a part of the process of amplitude modulation, where the carrier is modulated by the modulating or the information signal. After the modulation process, whatever the resulting signal is generated, that resulting signal having the two more different frequencies, and these two more different frequencies are we call as the sideband. These frequencies are generated directly above and below the carrier frequency. The carrier frequency is FC, and here above the carrier frequency is more than the carrier frequency, one frequency is generated and the other one frequency is generated. So the two frequencies are generated. One is above the carrier frequency and second one is below the carrier frequency. So the two different frequencies are generated. These two different frequencies are we called as the sideband. We had seen the process of modulation, and in that process of modulation we get the output equation, the modulated signal, and that modulated signal can be represented by using the equation. That equation is V2. That equation is V2, or we can say it is VAM, amplitude modulated voltage. So V2 is given by V2 is equals to Vc sin 2 pi fct plus Vm sin 2 pi fmt multiplied by sin 2 pi fct. Means here whatever the output or the composite signal is there, that composite signal is we call as the V2, the amplitude modulated signal, VAM. Okay, the complete theory about the amplitude modulated signal is given in the video lecture, and that video lecture I will provide in the I button or I will provide in the description box. So you watch that complete video, then you will understand this video lecture very easily. Okay, so the amplitude modulated signal V2 is given by the V2 equals to Vc sin 2 pi fct. This is the carrier, this one is the carrier, plus Vm sin 2 pi fmt. This is the modulating signal. The carrier we get Vc sin 2 pi fct plus Vm sin 2 pi fmt. This is we call modulating signal, and it is multiplied by the sin 2 pi fct, and this is also the carrier. So we get the equation. In that equation there is a carrier plus the product of the modulating signal and the carrier signal. Okay, so if we compare this above equation with the mathematical, or you can say the trigonometric identity sin A sin B, then we get the sin A sin B is equals to cos A minus B divided by 2 minus cos A plus B divided by 2. If we compare the sin A sin B with the above equation, then we get it is this equation is similar to this sine A, sine B. Here say this is the Vm sine 2 pi fmt multiplied by this sine 2 pi fct, means the product of the two signs, product of the two sign identities, and here these two sign identities are Vm sine 2 pi fmt multiplied by sine 2 pi fct. If we solve this, here this is sine A and this one is the sine B. The sine A, sine B equals to cos A minus B minus cos A plus B by 2. Cos A minus B by 2 minus cos A plus B by 2. Okay, so we solve this, then we get here the final equation. That equation becomes Vc sine 2 pi fct. This is as it is available. Then Vm by 2 cos 2 pi ft fc minus fm. There in that sine A sine B is equivalent equation A minus B. Here there is a fc minus fm, means A is the fc and the B is the fm. So fc minus fm minus Vm by 2 cos 2 pi t, again cos 2 pi t fc plus fm, means this is cos A minus B divided by 2 minus cos A plus B divided by 2. Okay, so we get the equation. That equation is Vc sine 2 pi fct plus Vm by 2 cos 2 pi t fc minus fm minus Vm by 2 cos 2 pi t fc plus fm. If we observe this equation, then we get the three quantities here, three terms here, and these three terms are, first one is the fc, the three frequencies we can say. Okay, so here we get fc, here we get fc minus fm, and second one here, third one we get that is fc plus fm, means as a part of the process after the amplitude modulation, here we get the three frequencies. First one is the carrier frequency denoted by fc, second one is the carrier frequency minus fm, and third one is the carrier frequency plus fm. So these two frequencies fc minus fm and fc plus fm are we called as the side frequencies or the sideband frequencies or only the sideband. This fc minus fm is we call lower sideband frequency and this fc plus fm is we call as the upper sideband frequency. Means after the modulation process, whatever the resulting signal is generated, that resulting signal having the carrier frequency fc plus it have one frequency which is less than the carrier frequency, we call it as lower sideband frequency, and other one frequency which is the more than the carrier frequency is we call as the upper sideband frequency fc plus fm. As a part of the process here we get the equation, and that equation is denoted by V2, that V2 is equals to the carrier, that is Vc sine 2 pi fct plus the product of the modulating signal and the carrier signal. Okay, if we solve this equation by using the trigonometric identity sine A sine B, then we get the equation, that equation having the three terms, or you can say the three different frequencies. These three different frequencies are we call as the carrier frequency, then lower sideband frequency and the upper sideband frequency. The first term is the carrier signal having the frequency fc and its amplitude, or you can say its peak voltage is the Vc. The second term we get, that second term is Fc minus Fm. It is the difference of the carrier frequency. Difference of the carrier frequency and the modulating frequency. It is Fc minus Fm. So this is we call as the lower sideband frequency FLSB. This is we call lower sideband frequency. Its amplitude is the Vm by 2. Means here the term we get, that term is Vm by 2 cos 2 pi t Fc minus Fm. One more term we get, again its amplitude is Vm by 2 cos 2 pi t Fc plus Fm. So first term having the frequency Fc and the amplitude is the peak value of the carrier signal, that is Vc. The second term we get Fc minus Fm. It is the difference of the carrier frequency and the modulating frequency with the amplitude of Vm by 2. This is we call lower sideband frequency or FLSB, lower sideband only, the LSB. The third term we get, that third term having the frequency Fc plus Fm, and here it is the sum of the carrier frequency and the modulating frequency. The amplitude of this Fc plus Fm term is Vm by 2. Again, the amplitude of these two sideband FLSB is the first sideband having the frequency Fc minus Fm, and the second sideband having the frequency Fc plus Fm. We call it as upper sideband FUSB, both having the amplitude, that amplitude is Vm by 2. That amplitude is the Vm by 2. So as a part of the process, when the amplitude modulation is done, the two different frequencies are generated. These two different frequencies are we call as, first one is the upper sideband frequency and the lower sideband frequency. This can be proved by using the mathematical, or you can say the trigonometric identity. That identity is sin A, sin B. If we apply that identity, then we get the equation Vc sin 2 pi Fct plus Vm by 2 plus Vm by 2 cos 2 pi t Fc minus Fm minus Vm by 2 cos 2 pi t Fc plus Fm. Okay, now here these two frequencies are we call as the FUSB and the FLSB. This FUSB and FLSB, both the frequencies having the amplitude, that amplitude is the peak voltage of modulating signal divided by 2, means Vm by 2. Okay, so this is the sideband. These two are the sideband. There is a question in the examination, what do you mean by the sideband? Explain it. Then you have to give the definition of the sideband and you have to explain with the help of the trigonometric equation sin A, sin B. We have to apply the sin A, sin B, and then you give the formula for the FUSB and the FLSB. FUSB is equals to Fc plus Fm and FLSB is equals to Fc minus Fm. Okay, now we have to see the frequency domain display. The frequency domain display, the display we use, if we have to see the graphical representation of any type of signal, then we use the CRO, cathode ray oscilloscope. But whatever the signal generated on the CRT screen, that signal is with respect to the time. Means if here the waveform generated, that waveform is the sine waveform, then that sine waveform is with respect to the time. But here the frequency domain display is different. The frequency domain display is different. The frequency domain display is plotted with respect to the amplitude, or you can say the frequency domain display is plotted by using this amplitude and the frequency. The amplitude of the signal is used and the frequency of the signal is used, so it is we call as frequency domain display. On the vertical axis we show the amplitude, and on this horizontal axis we show the frequency. So this display is we call as the frequency domain display, whereas in time domain display, on this horizontal axis we show the time and on the vertical axis we show the amplitude. It is the amplitude versus the time domain display, or it is amplitude versus the time display, and here the frequency display, frequency domain display means the signal amplitude versus the frequency is we call as the frequency domain display. We can show the sideband signals by using the frequency domain display, and a special type of instrument we require to use to display this frequency domain. That instrument is we call as a spectrum analyzer. That instrument is not the CRO. That instrument is not the measuring instrument like the digital multimeter. It is the spectrum analyzer. Okay, so if we use the spectrum analyzer and if we observe the display, then we get this type of display. This is we call frequency domain display. This is the frequency domain display, and the frequency domain display is that display which shows the frequency and the amplitude. The plot of the amplitude versus the frequency is we call as a frequency domain display. Okay, so in this display the three terms are shown. First one is the FUSB. First one is the FUSB. This FUSB having the frequency Fc minus Fm and its amplitude is Vm by 2. It is shown by using the vertical line. Okay, the second one is the FUSB. Here its frequency is Fc plus Fm and its amplitude is again Vm by 2. Third, at middle, it is the FC. It is the carrier signal. This is we call the lower sideband signal. This is we call the upper sideband signal, or you can say this is the lower sideband frequency, this is the upper sideband frequency, and the middle one is the carrier frequency FC. Okay, the frequency domain display gives us the bandwidth of the amplitude modulated signal, because there the two frequencies, the upper frequency is there and the lower frequency is there, and bandwidth is nothing but the difference between the upper sideband frequency to the lower sideband frequency. And here if we observe this diagram, then we get the bandwidth BW is equals to twice Fm. It is the double of the modulating signal frequency. For an example, suppose if a carrier of 100 kilohertz, a carrier of 100 kilohertz is amplitude modulated by the 2 kilohertz, amplitude modulated by a 2 kilohertz audio signal, 2 kilohertz only. The carrier signal is 100 kilohertz and the modulating signal is the 2 kilohertz. Then the bandwidth of the amplitude modulated wave is twice Fm, means 2 multiplied by 2 kilohertz equals to the 4 kilohertz. Okay, it is equals to the 4 kilohertz, means the sideband gives us the bandwidth of the resulting signal, bandwidth of the composite modulated signal. So therefore the bandwidth is important. The three importance of the sidebands are there. The first importance is the information is available only in the sideband. Why we are saying the information is available only in the sideband? Once again we look at the diagram. In this diagram the three terms are there. three frequencies are there, and all these three frequencies amplitude are given. Here Vc is the amplitude of a carrier signal, and here this carrier signal is the signal high frequency signal. Then second one is Fc minus Fm, that is the FLSB, having the amplitude Vm by 2, having the amplitude Vm by 2. It means here there is an information signal. The information signal's peak voltage divided by 2 is the amplitude. It means the information is available in the lower sideband. Again, the upper sideband FUSB having the amplitude Vm by 2. It means the information is also available in the upper sideband and the lower sideband only. The information is not available in the carrier. So therefore, there is importance of the upper sideband and the lower sideband. Okay. The another importance of the sideband is the bandwidth. It gives the bandwidth that we discussed earlier. And the second one is, since the two sidebands are generated, each of the modulating signal having the bandwidth is the twice Fm. Okay, so bandwidth we get. So bandwidth is the doubled of the modulating frequency. This is the importance of the sideband. In this video lecture, we had seen what is the sideband and how we can draw the frequency domain display. In next video lecture, we will see, in our next video lecture, we will see some examples on the amplitude modulation and the modulation index, and then on this sideband. If you understood this video, then hit the like button, subscribe the channel and share it with your friends. Thanks for watching the video.